This is a continuation of the section 1.4 material. We're going to work on an example from your book on page 42. This is example number 6. I can't show you the number 6 because then I'll have to be scrolling. So this information relates to death rates due to heart disease for the years 1960 through 2005, and the death rate is reported in hundred thousands of people. And this is as reported by the U.S. Center for Health Statistics. And again, this is from Lehman's text on page 42. So the first thing that we need to do for this data is we need to make a scattergram. So we've created a scattergram by first of all making a translation. This is T years after or since 1960. So 1960 is 0 years after 1960. 1970 is 10 years after 60. 1980 is 20 years after 60. 1990, 30 years. 2000, 40 years. And then 2005, 45 years. So the first thing that I did was I created a scale. So the scale you see here that I've created is independent axis T in years since 1960, and then the dependent axis R is the death rate in hundreds of thousands of people per year. And this axis I have broken right here with this jagged line, which tells you that there's a big break between 0 and 200, and that's 200,000 people per year. And then I've broken it up into 3 groupings. So this is at 33, and this is another 33, and this is another 33 approximately, so 33 and a third truly. So approximate values out here as a result. I could have broken it up into 25s, but this would have made my dependent axis just that much longer and more cumbersome. So I did it that way. And then the independent axis I've broken up by 5 years. So 5 years, 10 years, 15, 20. And these are all since 1960. So that was the first thing that I did. Now, then I have plotted the data points. Now, these data points I approximated because I don't have the scale accurately enough to have exactly those values. And to make exactly those values, I would have had to make such a large graph that it would have become very, very cumbersome. So I've approximated them from my first model, which we may see a little bit of in a bit. This point and this point were just a tiny bit off from where they really should have been. So I've erased them in Photoshop here and remarked them about where they should be. Now, after we draw a scatter plot or a scatter diagram, then what we want to do is we want to approximate it with a linear model. So I'm going to go here with my tool, and the first thing that I thought of doing is I thought, okay, well, I'm going to see if I can hit as many of these points as possible and then see where that gets me. And I think the first line that I drew, and I'll show you a picture of the first line that I drew here just a minute ago, it kind of hit it like this. So we had this point here being hit and the y-intercept here being on the line as well. And then what I did was I said, okay, well, let me see what the error looked like on that. So I'm going to flip over to 2 more PDFs of the pictures that I have with the error. So this was what I looked at as a first approximation. So you see here that I under approximated this one a little bit, and I hit that one right on, and then these were kind of over, and then I was hitting an x-intercept here of an exact value. And so I looked at the errors on that, and this is what the errors looked like for this model. So the approximate value at 559, I was looking at approximate value of 550 for my linear model, which gives me a negative value. So remember that errors in estimation, a point that above the line is an underestimate, and with underestimates we use negative values, and that's what I was showing you in this particular one. So we have the -9. And then my next one, again, this was over the line, so it's a -17. And then finally we have the positives and the positives and the positives. And when I added all these up, I got 25, which what I'm looking for is pretty darn close to 0. So I was like, yeah, I don't think that model's so great, so maybe I can do something else. So in the next little video, I'm going to show you what I did next, and that gave me the second approximation